this. We're going to pop over to, we're going to start the female. Oh, I need to share. Let me hit the share button. Screen share. Here we go. Okay, so we're going to start with the female reproductive system. I did check on Canvas, and one of the uploaded files was the embryo one. So there was only one set of notes, I think, that was uploaded that were the female reproductive. I can't remember if it was the 2-pager or the 3-pager. So I just re-uploaded these just a moment ago. That was why I was clicked off for a while. I was remaking them just so we had the exact one. So if they happen to be different, I didn't think they were, so I didn't think about it earlier. But when I checked, I did notice one of them was not uploaded correctly. Okay, we'll start with the female reproductive system. Let me pop this up to the full screen. And here we go. So the whole point of the female reproductive system is to produce some egg cells, be the site for fertilization to take place, and then to carry the embryo beyond that until it's ready to go out into the world on its own. So the female reproductive system looks like this. We can see the symphysis pubis here at the front part. That's sort of this bluish oval, so that gives you a reference point as far as the skeletal system. We have the bladder behind it, followed by the urethra out, and then this is the uterus that's kind of arching up and over the bladder. The cervix down here, and the vagina here. And then we can see an ovary up this way, as well as a fallopian tube going around to it. So we're going to go to a lot more detail today about this. This I just thought was funny because it was on one of my Instagram things. So this is quite a fairly anatomically correct little outfit. So this was a cute little way to start our reproductive system. The overall, we're going to be sort of looking at it from this perspective. If you watch the other lecture, that's the in-class from when I was using the board, we usually draw quite a bit out on the board because we're going to spend some time talking about the eggs being developed here in the ovary, which is labeled with an H. Goes through these little fimbriae, which is the G, that's the start of the fallopian tube, which is identified as F. The egg will come down. If it gets fertilized, it happens around here where the F is located actually. Makes its way in. This is the uterus proper over here. And then it would actually implant in the wall. We're going to spend some time talking about the changes within this wall, that being the endometrium. And then we have the cervix located here, and then the vagina. So in this picture, we can see, well, ureters are not in the right place. That's first of all. We saw a similar picture to this for the male reproductive system. So this is obviously just for the female reproductive system, where we can see how the fallopian tubes kind of fan out like some wings off to these ovaries on either side, and then how the uterus arches up and over the bladder. And if it's carrying a baby development-wise, you can see how the uterus could then go further up and expand further forward above and over the bladder itself. We could see the female's urethra with the vagina behind it. So regional anatomy, again, we've got, let me grab my pen here. So we have the bladder located here, the uterus here, ovary, fimbriae, fallopian tube, cervix is here, vagina is here, urethra is there. We have a number of ligaments that we'll go through. I think I have another separate slide for the ligaments, but we really can't see that many great ones in this, the ones I really want to show you. So let's see, well, this one's better. So what we have, I'm going to toggle back and forth so I can make the uterosacral ligaments are not in this picture, but they go from, let me go back to this one. And you don't really see them here, but they're really going from the uterus back to the sacrum. That would be the uterosacral. So you don't see them in either of these pictures. The round ligaments are located, the videos on this side here. Get rid of the video list. The round ligament is here, so we're going to go around. The round ligaments are actually tethering the uterus to the wall more anteriorly. Then we have these little guys here, but notice they have arteries and veins within them. Those are the suspensory ligaments. And these ones are really important because they also contain the blood vessels that are supplying not only the ovary, but the uterus itself. So the suspensory ligaments have these vessels embedded with them. So they're quite important. And then we have, let me see, make sure I say it, broad, it's not listed here, but you need to know this one too. It's on the next list. This guy here that's tethering the ovary into the uterus is the ovarian ligament. So we'll say there. And then last but not least, this sheet that we see here, that's known as the broad ligament. The broad ligament is wide. It really is like having the ovary, fallopian tube, a lot of these vessels laminated all together. When we're in the classroom, I have actually a uterus with the broad ligament intact in a container. So I usually bring it out and show it to you. I didn't really want to bring it home and show it to you here, so we're not going to see it this year. But it is, you can really, when you hold out the broad ligament, you can actually see the ovary and the fallopian tube and the round ligament, as well as the suspensory ligament and the ovary ligaments, all embedded in there together. It really is like it's laminated all together, and that's what the broad ligament does. So the whole purpose here of the ovaries is to produce gametes. In this case, the gamete would be the egg. Oops, my pen's not working. So the gamete is the egg. So in the female, for the male, the gamete would be sperm. We have the follicular development, meaning the follicle, that means like, so the round bubble that the egg is developing in inside the ovary, depends on the timing of the cycle. So we're going to be going through two main timings for the ovary, one before ovulation and one after. One is called the follicular phase, and the other is called the luteal phase. So we'll talk about that. So this ovary here is where this egg is developing, the egg being the gamete, developing inside a follicle. And then it will get launched out into the fallopian tube here. So it's a really nice view of an ovarian ligament as well. So the process of oogenesis, this means development and creation of an egg, comes from the main germ cell. So we have the germ cell within the ovary. All females have all the eggs that they ever will have in their body by the time they are a 3-month-old embryo. So, conceptually, and I want you to understand that a woman that is pregnant with a female baby already has the eggs in her for her future grandchildren. So all of the eggs that a female ever will have is going to be present by the time she's an embryo. Then these eggs do not complete meiosis. So they're in this halted state. They're unlike sperm, where they just go through meiosis and you end up with sperm and you can just continually make them throughout the entire life. Females have a fixed number of eggs. The number declines slightly after birth, and then it holds steady. And then once a female hits puberty, obviously several eggs are actually going to go into development. Only one usually gets actually ovulated. And so each cycle, or each month, which is generally about a month long, it can vary, it could be shorter or longer, will then utilize some of these eggs in this halted meiosis state. So from the embryo point, that this female was an embryo, until she hits puberty, the development had gone through meiosis 1. It hadn't finished the second meiosis phase yet. So then once one of these meiosis 1 stage eggs are being tasked to develop, say during an ovulation cycle or in a cycle to be ovulated, it only gets as far as metaphase 2. Metaphase 2 so it's still not completed all of meiosis by the time the egg leaves the ovary and is ovulated. It only completes full meiosis after sperm has penetrated the wall of the egg. So I put in the squares around the important benchmarks that you realize that not only are eggs present in the female from the point she's an embryo, but they have not completed meiosis, and they're only to the point of meiosis 1 until puberty, and then thereafter only the eggs that are undergoing further development, that say are going to be progressing to be ovulated in a given cycle, the most it's going to develop to would be metaphase 2. Only meiosis will only be fully completed for the female egg upon the moment of fertilization, or not when the sperm actually penetrates the egg. Then meiosis will complete, and then the chromosomes can line up next to the male's chromosomes. So you can kind of see, as far as a primary oocyte, we're going to go through these stages of the different oocytes until the egg cell. So we're going to follow this larger pink version. As the male, you end up with 4 equal cells of 23 chromosomes. For the female, for the egg, you actually still end up with 4 cells, but you end up with 1 main cell, and these other polar bodies just get sort of wasted away. So although technically you still make 4 cells, only 1 is going to be the one that was viable as an actual egg. This is just another slide to sort of break it down a little bit more as far as the development of the egg process. The main thing I want you to know, outside of the stages of meiosis that had a red and a blue block around it, those would be the main benchmarks as far as specific to meiosis that I would want you to know. The primary thing I'd like you to focus on here are the actual follicles. We have 4 main follicle stages that you need to know that the egg will develop through within the ovary. So it's here as a list, just like we had a similar list for the stages of sperm development, where we had spermatogonia, primary spermatocyte, secondary, and so on. So this is sort of your master list, but we're going to talk about each of these utilizing the images on the following slides. So this is a slide from a cat ovary. So I point that out because, unlike a human, there wouldn't be quite as many eggs in the development stage, because cats have litters of kitties, so obviously more babies than a human would. But we have a better opportunity to slice open viable ovaries to see the development stages than we do for humans. So I want you to notice these little guys way out here in the periphery. This is the edge of the ovary, and see all those tiny little circles? Those guys are known as primordial. Sorry about my bad handwriting, and I'm writing up on a screen in a weird angle, so this should be an O here. Primordial follicles. They're the first ones on your list. So this is the level, these are the eggs that the female has since she's been born. They're tucked off here into the edge. They're just hundreds of thousands of them just plugged in there. When some of these follicles, say anywhere from 5 to 20, get pulled out or sort of initiated for development in any given cycle, they become a primary follicle, and the primary would be located here. This looks like actually kind of a dying off one. This is a later stage primary. You don't see that many primaries in this one. Maybe this one. This is just coming to the end of the primary. So this here would be a primary follicle. Those primary follicles are now starting to develop. You can see, instead of having, real small, thin cells around the outside that you can't even see around the egg, we can actually see cells starting to develop right around, but they're staying tight around the egg itself, which is defined by this pink line. Then they move to, I'm going to erase this part, secondary follicle. And the secondary follicles are starting to get a little fluid pouch within them. So this is supposed to be an arrow. You can see a little fluid pouch starting to develop here. We see a little fluid. This is an antrum, the fluid is. So This would be a secondary. This is another secondary. And this is another secondary. So notice the difference between this guy. I should change the color. The red just is not doing very well. I need to, sorry, move the video, or the videos are now at the bottom of my slide. Let's see, let's change to like a blue, oh, maybe a green. There's no green on here. So if this guy here is a primary, you can see that there's no antrum. The antrum is the fluid filled. Let me sit there and make that blue. This fluid area, I'm just gonna write it in this bigger one. That's an antrum. That's the fluid that's developing within there. So we can see the secondary follicle has a bit of an antrum growing. We can see this one here has a little, the fluid's just starting. So that's an early secondary. This one also is kind of an early secondary as well. So I'm trying to color in the antrum portion while the red is still circling the secondary follicles. The green is around the primary follicle to show that it has no antrum. There's no fluid within there. So we could see that the red circled ones are a little bit more further along in terms of development. And then finally, this larger one that I wrote the word antrum in because it's so much larger is going to be known as a mature, also known as Graphian 2A's follicle. Okay, so these are all the stages that you're going to need to know. This sort of all the stages of follicular development, but I want you to think now in sort of a big picture. Throughout the course of a month, say 28-day cycle, if we talk about that's the average cycle, the course of a single 28-day cycle, these follicles are in the ovary developing. So this is known as the follicular phase. The follicular phase happens in the first 2 weeks of a female's reproductive cycle. These follicles, they go from primordials, which are out there on the edge. They, you know, not all of them, a few of them, anywhere from 5 to 20, up to 20. That seems like a lot, but I usually say 10, but I read a couple things that sort of expanded that number, but it still seems quite high. So I'll sort of stick with 10 as sort of being somewhere in between, a little more conservative. So say in a given month or a given cycle, 10 of these primordials we're going to develop into primaries. And maybe not all of them develop appropriately. So maybe by the time if we pull 10 primordials out, maybe we'll end up with like 7 primaries. And then an antrum starts to fill. And only say 2 or 3 start to develop appropriately and develop an antrum. So you can see some of the follicles are falling off and not further developing. So the ovaries' energies can go towards the greater developing ones to when we finally end up, hopefully, with a single mature follicle. And that single mature follicle is going to then what's ultimately going to be ovulated or ejected out of the egg. This, again, is the follicular phase. The follicular phase ends at the moment of ovulation. The other thing I really wanted to point out to you, and I'll put this in like yellow, the egg itself. So obviously the eggs are these little yellow guys here, and they're primordials. Then the egg is everything under this pink line. So we have the egg within here. And then you can see the egg within here. I'm drawing in yellow, trying to keep the pink line around that. I'm having a hard time drawing. So we get to the mature one. This is in a weird angle here. Sorry, I'm drawing like I have Parkinson's disease or something. A little wobbly. So that is the egg. That, along with its protective layers, which I have a slide on as we go, but I'll just color them in orange. Well, one of the protective layers is the pink, and the other is this here. That sort of weird little yellow flower with the bright yellow in the middle, the pink rimming around it, and then the orangey curlicues out that side of that. That is what ultimately leaves the body, leaves the ovary. That's what gets ejected out the ovary. So we have the yellow egg, and we have 2 protective layers. you want to write them in your notes, we have them probably written somewhere down the line. But the protective layers are, well, this curly one out here is known as corona, nothing related to the coronavirus, radiata. It's just a whole bunch of cells around the outside of the egg to protect it while it goes down the fallopian tube. And I'm going to switch colors to, well, I'll do red. It's sort of representing the pink here. So I'll go here. And this here is zona.
Scarlett, no. I mean,
does anybody have any questions? Okay. My volume is low, so if you have a question, shout out or throw on the chat. So the corona radiata and the zona pellucida are the protective layers where the yellow part is the egg itself. Okay, so it looks like I made quite a mess of this slide. We'll be going through these in order, one by one. So if we talk about, let me switch my colors back over to blue. The primordial, remember that's the one out in the periphery. They're really thin. So this is a primordial. We have really thin squamous cells around the outside and then the egg proper inside. These here are primordial follicles. This is sort of a zoomed in view of an ovary. This guy here, just so we can see it, is a primary. So the primordials are really thin on the outside here, primordial. Write that here. So that's primordial, but notice the next stage that we're about to talk about, how it has little cuboidal cells around the outside. So this one's starting to get developed, where all these primordials, this is how the eggs are from the moment the female was born. So the primary, that's the one where now we have more cells developing around it. So these guys in these two pictures at the bottom are primary follicles. So we see again primordial, C-R-I, primordial, and then we have the primary. This is a primary, this is a primary. These guys are, so you can kind of see the difference there. They're starting to develop. This is occurring in the first week of, actually this is happening the very week that the female is having her menstrual period. So it's actually why when they talk about what the first day of your period, if you're a female, is actually the first day of your new cycle. And it doesn't seem to make sense. You think, oh, with my period, that would be the end of a cycle, right? It is from the perspective of the uterus. The uterus is like getting rid of the old. From the perspective of the egg, the start of the period corresponds with the development from the primordial into the primary. So the cycle is really determined on what the egg is doing. And it just happens to correspond. So this is the week that corresponds with the first week of the female cycle, which happens to be during the menstrual phase, also in the uterus. So then we go from the primary, we go into a secondary where we start to get this little antrum filled here until we finally get to a full-on mature or a Graafian follicle where you can see the antrum is a lot bigger. But what we've really retained is the egg part. So what I've got circled here is we have the egg or ovum within there. We have the zona pellucida in black, and we have this corona radiata there that I'm sort of made into a flower looking thing. And then you can see that same port here. So when we ovulate, that's what's get ejected out. The other stuff, the rest of the follicle stays behind in the ovary, and it has an important job to do in the ovary that stays behind in the after ovulation portion. So this is a picture of a giant mature follicle. We see some of the primordials up there. We see sort of some like left behind primary follicle that really got stunted, didn't develop anymore. But we have this big conjunga Graafian mature follicle with the egg right here. And so this is actually migrating off to the side. It's moving its way up to the edge of the ovary here. And ultimately, this is what's going to get launched out. Oh, I wonder if this works. This was a cool animation that I had found last semester. Okay, I guess I have to go click slide by side. So what I want you to see is here is the egg. What you see around the periphery of the egg is those rest of the follicular cells that's around that antrum that's going to stay behind in the ovary. So here's the egg getting launched, getting ejected. The egg is now going to be on its way, but I want you to see that this is left behind, and this plays a very important role after ovulation. So here the egg is now on its way. It's not quite done with meiosis. It's in its metaphase 2. We have these follicular cells that are behind. We have the egg that's been launched out. And there we go. So this is another picture of the ovary, and we can see it's actually this leap of faith. It is the fallopian tube is not attached to the ovary. So literally, and I'll go back a slide here. Literally, you can see here, they're not attached. So when the egg is ovulated, it's literally propelled like a slingshot. Obviously not like a slingshot, but you have to have the ovary provide some propulsion, and the egg is quite literally ejected out with a significant amount of force to launch it. And hopefully the fimbriae, which we have yet to define, but that's what they're called, the edges of this fallopian tube here is going to be like a catcher's mitt, and these fingers are going to help draw the egg inward so it can actually go into the fallopian tube. But it may not. There might be instances where this egg wings out and now you're, hello, in the abdominal cavity. So it's, you know, the fallopian tube's there, but it's not attached. Okay, so we can see another picture here. Here's a fallopian tube. We have fimbriae here, and then we can see the egg being launched. And actually see how fuzzy it is. The cells that you're seeing, those are those corona radiata cells. So, okay, this, I want you to see this. I'm going to go back again. So this picture, this part there is known as the corpus luteum. That's the leftover cells. And it's super important that you know that that's where progesterone comes from. So that's what we got going here. So I'm going to go back to the earlier pictures here. Oh, wrong way. This picture. So once the egg has left, the corpus luteum is developed from the leftover follicle. So I'm going to go even further back. So we know the egg part leaves. So all of these cells here stay behind and become the corpus luteum while the egg part takes off. So let me change colors. So the egg part here is gone with ovulation out. And then the remaining blue cells that I just did a curly cues around stays inside. So there we go, that I circled in blue here. Those guys are now, this is a real human ovary, and see how huge it develops. It puffs up and gets really, really big, and it literally becomes a progesterone gland. So this here is the luteal phase. The luteal phase is in the last 2 weeks of a female cycle. So the first 2 weeks, if we're dealing with a 28-day cycle, so 4 weeks, the first 2 weeks was the follicular phase, developing the follicles. The moment of ovulation is just a single moment, so it's not really considered a phase. So you have the follicular phase leading up to it, you ovulate, pitch that egg out, and then the last 2 weeks are all about secreting progesterone, and the corpus luteum, which is that follicle that was left behind in the ovary, is just churning out progesterone. The reason why we need progesterone is it's targeting the endometrium, telling the endometrium, the egg is on the way, you better start secreting out nourishing substances in case this egg gets fertilized, so that it has some place to implant. So implantation, there are viable eggs being implanted inside of a uterus the interface of the inner layer of the uterus being the endometrium, the level of progesterone is critical. And in fact, many women that are of reproductive age or have been on birth control and then are trying to get pregnant after they get off birth control, their issue is not so much not ovulating. Their issue more frequently is lack of progesterone and lack of a development of an endometrium. So this is another slide showing how much larger even this luteal, this is called the corpus luteum, this thing. So look how huge this thing is. It takes up almost the whole ovary. It's giant. It's just churning out progesterone. It becomes this humongous progesterone gland. Okay, I don't know what that was for. Okay, so now we know in the ovary, we know the first 2 weeks develops the egg. We launch the egg out. Hopefully it makes its way here into the fallopian tube that we'll talk about these phases. And then the second 2 weeks, we have this corpus luteum inside that makes the progesterone. So that's the recap of where we've been. Now we'll talk about some anatomy as we move along. So we have the fimbriae. I've been talking about those. Those are little blue ends, the finger-like projections. It's trying to grab the egg, so it's going to bring it into the fallopian tube. We have this little funnel area called the infundibulum. And then as it narrows down, we see the ampulla is really the corner, and then it's the main fallopian tube. And it's really here on this corner at this point is the main place that an egg would get fertilized if the sperm is in the area. Then we can see that here. You can see fimbriae. Oh, now I need a different color. Back to blue. We have our fimbriae, infundibulum here, and then we have our ampulla, put an A here. This is the main area fertilization takes place. We have the rest of the fallopian tube, and ultimately the egg will implant in the endometrium. As the egg, so here's the egg, we can see here on this side, and then look, it's got tons of sperm trying to penetrate the egg. But I also want you to see, look at all the cilia that the egg is sitting on. It's sort of like seaweed. And the egg is such a giant cell that the cilia that we see here is actually lining the edges. So this here is the fallopian tube itself, but it's not an open tube like a straw. It's kind of like the ureter, where it's a little more encroached upon than we'd expect it to be. And so because the egg is kind of wallowing through this scrunched in fallopian tube, it's just not rolling down it like a marble through a tunnel. It actually has to be moved like somebody in a mosh pit. You know, it's a terrible analogy, but it's all I can think of is people moving somebody around in one of those crazy concerts. Okay, so this is just a beautiful slide. You can see the sperm trying to penetrate. We see all of these cells here. That's the corona radiata. So we're not seeing the egg proper. We're just seeing the protective layer on the outside. If you guys can remember, what was the little helmet portion of the sperm called that's actually releasing enzymes to help it penetrate? It swims through the corona radiata. It's actually penetrating, trying to penetrate the zona pellucida. And hopefully you said acrosome. That's the acrosome with a little tip on the sperm head that's doing that. So now we know most of the parts. We need to talk about the uterus. We haven't talked, hopefully that's next. Okay, we're still in the fallopian tube, or we'll skip that. Okay, so we're on to the uterus. We have the uterosacral ligaments that are going back, the round ligaments which are going forward, and the suspensory ligaments that come out to the side that have the blood vessels. And then we have the ovary here, and then we have the ovarian ligament. Why do I not list those? You should know the ovarian ligament. I'm going to write it on here. The ovarian ligament connects the ovary to the uterus inward. Okay. The anatomy of the uterus, I thought I have a picture here, sorry, I moved it forward, is the fundus and the isthmus. The main thing I really care that you know about the uterus, let me go back to this uterus here. The fundus is going to be this upper portion, and the cervix, which is actually projecting down into the vagina, is the lower part of the uterus. And a female goes and gets a pap smear. It's a really long Q-tip that goes up the uterus, and they do a swipe across the cervix. If any of you guys did in your prerequisite class in like Bio 181 or 156, where you would take a cotton swab and swab the inside of your cheek, and then you could look at your cells. Well, that's exactly what a pap smear is. They're just taking it from the cervix, which is a sample of the bottom of the uterus. Because the cervix changes each month, it actually gets really, during ovulation, it's more hospitable and changes and softens a little bit to allow sperm through. But throughout the rest of the cycle, it's blocking sperm, it's preventing anything from coming in because it's trying to prevent any infection coming in from the outside world. So because it changes throughout several weeks, it's actually more, could be a site for cancer development because of the regular changes occurring at this location. So it's really, really important that women get annual pap smears, because this type of cancer can sneak up on people if they don't, and it can get very, very advanced before someone is even symptomatic. So it's really important to get a pap smear, and it's sampling the cells along the cervix. Okay. The hole is known as the cervical os, OS, and then you have the internal os, which is actually the inside portion, but we just call it the os, or cervical os. So the layers of the uterus, I've talked about the endometrium several times now, because that's the important layer. That's the innermost layer that a fertilized egg is going to attach to or be embedded within. I'm going to change this to red. But remember, we talked about progesterone from the corpus luteum. This here is going to cause it to actually secrete nutrients. Before progesterone can, we have to build it up. Estrogen's the builder. Progesterone is more the turning on all the, turning on the glands. Estrogen builds the glands. Progesterone actually makes the glands become active. The myo, the prefix myo just means muscle. So this muscle layer is the thick muscle layer. It is about 1 centimeter thick in a regular uterus. It doesn't have a baby in it, but during pregnancy, it can actually increase. Not only is the uterus increasing in size, but the wall gets quite a bit thicker. And then there's a serous coat, which is more this outer, just connective tissue layer. This is the endometrium itself. So we're looking at, let me go back to a regular, this here. So if we have this here is our endometrium, I'm just going to do it in red, then the area that's highlighted, that's indicated by the letter E, is the myometrium. And then the outer, say, orangish layer here, I guess D might be representing, I don't know, is the serous, just sort of a connective tissue. But this E is the thick wall of the muscle layer, that's the myometrium. But we're really focusing now here on that, which is the endometrium. Now the endometrium is going to have 3 phases. It starts off, although logically, well, let's go in the logical phase and then we'll move to the actual phase. No, I better just do it the normal phases. The first phase is actually the menstrual phase. And that's where this endometrium, let me erase that, is actually falling apart. It's just breaking apart like an avalanche on a hill, and it's falling out. And that's really what menstruation is the breaking down and getting rid of old endometrial tissue. And then, let me change colors. We'll say number 2, we're going to call this the proliferative phase. And the proliferative phase is actually the rebuilding. So we're going to remake this endometrium. It's regrowing. We've got glands growing within here. I'm just drawing little circles. And it's rebuilding. So this is happening in right after the menstrual phase. Both of these occur, so over here, before ovulation. And also remember, in the ovary itself, we have the little primordials becoming primary, and then ultimately becoming a mature follicle. So in the ovary, it was known as the follicular phase. So the follicular phase of the ovary is happening when first the menstrual phase is happening in the uterus, in the endometrium, and then the proliferative. So we first in the endometrium, we get rid of the old, and then we rebuild. At the same time in the ovary, we're developing the follicles. Then, maybe we're going to change colors for this next part. Green, we'll call it green. Then at this point, we ovulate, and now we have the egg is ovulated. It's on its way, so we'll erase the egg from here. And now the follicular cells are puffing up, becoming that corpus luteum. So now it's known as the luteal phase in the ovary. What does the corpus luteum make? It makes progesterone. And the progesterone actually targets the endometrium, and we are in the secretory or secretory, however you want to say it. That phase is going to be after ovulation. And what's happening is the progesterone from the corpus luteum in the ovary is actually targeting the glands in the endometrium, causing them to secrete a glycogen type nutrient substances, so that if this little egg gets fertilized and gets implanted, there's actually something to feed it and to help it grow and develop. So the progesterone activates the glands. So this is pretty messy here. We're going to go through this again. This phase is actually what we're going to start our next lecture about, just so we can recap it. But for now, we're going to look at some of the histology slides. So this image here across shows you from, like, this would be day 1 through 7. If someone has a menstrual period that takes a week long, sometimes they're 2 days, sometimes they're 10 days, but we'll just call it week 1, day 1 through 7. This here is the menstrual period. You can see the endometrium falling apart, and it's going to literally be falling out of the body. That's what the period is. And this is histologically what it looks like. So this here is the myometrium, so that doesn't leave. So we have really down to hardly any endometrial layer. It's just have already gone and broken apart. Then, so we can call this week 1. Then say we're gonna go here to, so day 7, get rid of that W. Day 7 through 14, if we're dealing with a normal 28-day cycle. So this would be week 2. This is known as the proliferative phase. So it's already written in the bottom. And I put week 1 to 2, because if the menstrual phase only lasted 2 days, well, then this would be day 3, 4, 5. It just basically is whenever the menstrual phase is done. Generally, women with more estrogen have a thicker endometrium, and then therefore more progesterone, because you always want to balance. It doesn't matter. It's not a contest who has more or less. It is, if you're a woman that produces more, then you also need more corresponding progesterone. If you don't produce as much estrogen, that's okay, but you still need to have a balance of progesterone with it. But generally, more develops a thicker endometrium. So women that have longer and heavier periods have more estrogen, progesterone, because they made more tissue, essentially. So week 2, this is a proliferative phase. It's just rebuilding. So look at the glands there. They're just little circles. You might see later, like towards, day 12, the circles are now ovals. They're more, the edges are more defined, like a nice little circle. They might be ovals. But I want you to see over here in this last phase, the secretory phase, the circles or the ovals are all squiggly. You see the squiggly lines. It's now more mature, and this is where, the arrow there, progesterone, to abbreviate, progesterone is actually causing those squiggly glands to now secrete nourishing substances. So you'll see actually within these little spaces are going to be glycogen, pools of glycogen and other nutrients. So that if the egg, let me switch colors here, go to a bright yellow. If the egg actually gets burrowed in, it's fertilized and it's burrowed in the wall during the secretory phase, it's going to be burrowed in here, it actually can tap into these little glands, and that's what's going to feed it until it actually develops its own placenta and gets a blood supply. So during the proliferative phase, after the menstrual phase, after we got rid of the old endometrium, we are going to now build anew. So this is some glands in there. We see these little new developing, very prominent, more geometric edges. You can see that here, a little further developed. The glands are being just made. This is dominated by estrogen. Estrogen promotes growth. It's also why it's considered a cancer risk. But when it's doing its job, it's promoting growth of the endometrium after menstruation. We don't want estrogen just to go hog wild and cause growth all over the place and increase breast cancer risk. No, estrogen has a very specific job. Tell the endometrium to grow, but also, hey, liver, get rid of estrogen. And we talked a little bit about while we were in class, how we can actually detoxify and get rid of estrogen, whether it's through the 2, 4, or 16 conjugation. The 2 is the least reactive and cancer promoting, where the 4 and 16, if a female breaks her estrogen down in the 4 and 16 pathway, they tend to have a higher risk for cancer because those could potentially cause more mutations. Anyways, that's a sidetrack. So what you need to know is after the menstrual phase, which is week 1, whenever the menstrual phase ends, the proliferative begins and estrogen levels rise and they cause the endometrium to grow because estrogen is a growth promoter. And this is what it looks like. For your exam, on your Unit 4 exam, you will see pictures of the endometrium, and you're going to have to identify, hey, this is a proliferative phase. And then I'm going to ask you, what's the dominant hormone during this phase? And you're going to say estrogen. I might say, what week is this phase occurring? Week 1 to 2. Or you can just make it easy. Menstrual phase is week 1, proliferative is week 2, and just leave it as that. Now, after ovulation, the ovary is turned into a progesterone gland. Progesterone is now secreted. It's targeting the endometrium. These glands that used to be circles or ovals, really defined edges, are now weird squiggly glands. And it's these squiggly glands that now have secreted material. You can see that here. So we see all of this really good nourishing stuff that if a fertilized egg implants, really has plenty to eat, essentially, so it can develop. So the secretory phase, this is in the uterus, corresponds with the luteal phase, meaning the corpus luteum, in the ovary. So here we have proliferative phase, week 1 to 2. We have the endometrium is really thin, but it's just starting to grow. So this is the early proliferative phase. And I thought I had another one right after that. So all of this is taking place right here on this endometrial area. Okay, this is again another picture of a uterine wall. This is the endometrium. We see some glands. This actually would be a secretory phase because glands are a little bit bigger. Okay, so now let's finish some of the basic anatomy. We have the vagina, which leads out from the uterus. Its semen's actually obviously deposited here. So sperm within the semen has got to make its way from the vagina into the cervix, crossing the cervix into the uterus and then out the fallopian tubes. So this is the birth canal. Menstrual flow comes out this way. There are a number of mucous membranes. Before a female's had sex, there's a barrier known as the hymen across the way. It's not always present in all people. It can actually be torn easily when they're younger. Okay, external genitalia organs. So just outside basic female anatomy, the vulva is all of it. The vestibule just means space, so it's just the opening area. So the folds are known as labia. majora, and minora. So majora means the larger outer folds, and then you have some smaller internal folds, inner folds that's surrounding more the vaginal as well as the urethral openings. There are a number of glands. I just have 2 listed here, but there are a number of different glands. Paraurethral, meaning obviously para alongside the urethra, and then vestibular glands. Obviously the vestibule is the opening into the vagina. These are glands that are going to be near the opening there. And then in the most anterior area is the clitoris. So the clitoris, or clitoris, however you want to say it, is actually made of erectile tissue that is analogous to what's found in the male penis. And so this is at the apex, and so there are some very much analogous anatomy across males and females. So let me switch colors on this slide here. Okay. So we have, obviously you can see there's glands located here, the paraurethral and the vestibular glands. This here is the clitoris. It's showing a slight picture there, kind of shows the sort of cavernosus, like the corpora cavernosa. It has some of that erectile tissue, so it can actually enlarge during sex and get, because of the erectile tissue nature. We have the urethra here, and then this is the vagina. Notice, one of the important things I like you to notice is this is the cervix. This is the bottom of the uterus in the vaginal cavity. But notice this is actually why the uterus is tipped. It sort of makes like a number 7 off to the leaned over a number 7. You don't want the cervix to be the very end and the uterus to be like this, because it would just get pummeled like a battering ram. It's actually important that it's kind of tipped off to the side, so it doesn't get damaged during sex. But also, when semen is deposited here, it stays there and it allows for it to kind of, the fibrinogen components and all the other fluid components allows it to stay and stick there, so that sperm can then make its way into the vagina, into the uterus, and ultimately out the fallopian tubes and be literally at the ready. This is where the sperm needs to be if the egg is going to get fertilized. So having this actual positioning of the uterus, if somebody has a retrograde uterus, it means the uterus is actually flipped up and it's more along the lines of the ovary, or of the vagina, and it reduces the chance or makes fertilization a little bit harder. So the position of the uterus to the vagina in this 7 sort of configuration actually makes it easier for when seminal fluid or sperm is deposited here, for the sperm to make its way in. Okay, so let's talk about breast tissue. Males and females start off with the same breast tissue. You got little boys and little girls, same breast tissue. You throw in a whole bunch of estrogen in a female during puberty, and she's going to develop breasts. Now, if you threw a bunch of estrogen in a male, anytime through his life, he'll develop breasts too. And in fact, males in later life, fat in their abdominal belly generally converts their testosterone to estrogen. So many men actually develop breast tissue later in life that is similar breast tissue to a pubescent female. Now, this is not to make them feel less manly, this is to point out that they're actually at increased breast cancer risk at this point, because they have tissue that is actually being stimulated to grow by just the presence of estrogen. Okay, back to breasts in females here. It tends to sit on top of, does sit on top of the pectoralis major muscle. The breast size is really determined by fat. So you can have small-breasted women and really large-breasted women. They both have the same lactating potential. The size is more adipose content, not gland content. So the glandular components are the same. The lobes of glandular tissue, same in men and women. Now, obviously, men are never going to lactate no matter how much estrogen you give them, but men, their glands are the same. We sort of have the same equipment in there. But women, because of their higher levels of estrogen, make it from, say, if we have 4 stages of breast development, let me just pop this share and just talk to you here. There's 4 main stages of breast development that women go through. So stage 1 would be little kids, boys and girls, same type of breast tissue, all the same amount of glandular tissue. You get an estrogen surge, which happens in pubescent females, and you get into stage 2. So now breasts start to grow, glands start to become not quite active, but they start to enlarge. Okay, and then the estrogen levels in the female allow for fat accumulation in, rounded hips and thighs and increasing breast size. Okay, so that's going on. We're in stage 2. Stage 3 happens when the female gets pregnant, early pregnancy. And so breast changes happen here in anticipation of lactation in 9 months. So there's a lot of changes. That's often the first symptom females experience, also besides missing their period, that they think they're pregnant, because there's some breast changes that take place. Stage 4, and the final stage for breast development, is really when after the child is born and the female can nurse. Now, I don't want to get into controversy whether nursing is good or bad, or one way or the other, but the potential to nurse. So whether they choose to nurse or not, the fact that they can, and they are indeed lactating, and they are indeed producing milk, and milk's coming out, that's stage 4. So then, in a way, that is why pregnancy is more breast protective for women, because now they've completed the growth cycle and the growth stages. So it doesn't mean plenty of women have kids and they have breast cancer, but you are more at risk if you, didn't have a child, and so you're really just at stage 2. You have more growth potential. So that it can actually go wrong more easily. Or if you had one pregnancy that, if you have yet, so it doesn't matter how many you had, I guess, if you have yet to complete a pregnancy, so whether there was a pregnancy and a miscarriage or abortion, or either way, it never came to fruition. Now, if you finally have a pregnancy that comes to fruition, then you've completed the cycle. Whether you have subsequent miscarriages is irrelevant to the breast development side of things. So you can see where men, they only can get to breast level 2. They're early at 1, and if they have a lot of estrogen being produced later in life because their testosterone is getting converted because of fat, there's an enzyme in fat that actually causes the conversion over. And so they could get to breast, they're never going to get lactating, so they never can get to stage 3 and 4. So they actually are at one of the more volatile stages, and that's why men later in life are actually at risk for breast cancer and need to be checked out for that. So I've known of 2 men, or 2 of my friends, fathers that actually had breast cancer and have had to have that addressed. So it's something that's not common, but it's also not necessarily unusual either. So we'll go back to our lecture. We're almost done here. So let's go through some. I want you to see there's suspensory ligaments that holds the breasts up. So if you get saggy breasts later in life, it's blame the suspensory ligaments for not doing their job. We have lymph vessels and nodes, the lactiferous sinus. Okay, so here are the, pen, glands, and then we have the ducts. The ducts are all bringing the milk down in here. And then these enlarged areas here, that's the lactiferous sinus. It's sort of like the holding tank for milk if a female is lactating. So all women are going to have the same amount of breast tissue during lactation, during the time they're actively lactating. This can enlarge, make milk, and then milk hangs out in these lactiferous sinuses. You can see here's the pectoralis major muscle. These are suspensory ligaments hanging on there. We also have lymphatic vessels. That's also why if you have breast cancer, some of these nodes or nodules start to develop. You don't want them to go into, obviously, the lymph nodes. Most people are familiar with that process. So this is not part's not on your test. It's just showing you, actually, aromatase is the enzyme that actually takes your androgens, testosterone being one of them. The aromatase turns it into estrogen. Estradiol is the main estrogen. Estrogen, there's really no hormone called estrogen. It's a hormone group. There's 3 hormones: estradiol, estriol, and estrone. Estradiol is the more impotent one. The estrone and estriol we see off to the right are higher levels during pregnancy. Okay, that's it. Let me just stop the sharing. Okay, so here we are. We went through female basic anatomy, kind of introduced you to the phases. You want to think of the ovary. You've got the follicular phase. You should know the 4 types of follicles within there, the primordial to primary to secondary, finally to the mature. Once ovulation takes place, then you're in the luteal phase because the follicle turned into the corpus luteum that now makes progesterone. Then we learned about the endometrium in the ovary. It had the menstrual phase, getting rid of the old, proliferative, building up new, estrogens driving that. And then finally, the ovary over here sending out progesterone makes the endometrium secretory. So it's getting ready for an egg to come in and implant. So those are the important things that we're going to recap when we come back at our next lecture, because we'll talk more about the phases. We're going to actually correspond that with a calendar, and then we'll move on from that point and talk about what if sperm shows up and now we have the egg, not just here's the egg getting out of the ovary, but what if it gets fertilized on the way, and then how it implants and develops within the endometrium and how it utilizes the resources of the glands there to develop. So any questions from today? All right, well, that's all I got for you then. So I'm trying to make it nice and easy. Normally in class, we'd be spending time looking at histology slides and wanting you guys to identify the menstrual phase, the proliferative phase, the secretory phase of the endometrium, and then we'd also be looking at 2 slides for the ovary. We'd be looking at a pre-ovulatory phases, which would be the follicular phase, and then we'd look at a post-ovulatory phase, which is the luteal phase. So I would recommend that you Google, say, proliferative endometrium histology. And if you throw in histology, you're actually going to have a better shot at getting better images. You could type in, menstrual endometrium histology. And so you want to look at some of these images. And I think I have some on the worksheet also for you to have to look at. I think I loaded the worksheet. I know I did the video that went through the worksheet answers. I can't remember if it's loaded up or not. So I'll check after class. So that's normally the lab activity that we do, is just all histology. And you could do that at home now. You can Google those things and look at them. And then I recommend, writing like in your notes, do a cover, like a cheat sheet for the female reproductive system. You might want a little diagram, and you might want to, on this diagram, draw, the ligaments and draw the layers of the endometrium, draw the fallopian tube and the fimbriae. You got your basic anatomy. And then you could, put a little arrow out and draw like little thumbnails of the menstrual phase, proliferative phase, secretory phase, so you can see them. And then I'd put next to that, the proliferative phase, probably estrogen. And then next to the secretory phase, right, progesterone. Then you know which hormone's actually driving that. And so you want to kind of make that fairly complete today, so that when we come back and recap that, you have a quick reference to go over and be able to either add to the notes or bring up questions if you have that point. And then we'll talk about it again with the timing, which days and the weeks and what hormones are going on and so on. All right, that's it. Let me know if you have any questions. You can make an appointment with me on my link that's on Canvas, or just shoot me an email, or just shout it out.